Hello everyone, welcome to discussion 6 for CS61B. Today we're going to be talking about packages and bits. Short mini lecture today, just going over the stuff from lecture. So first of all, access modifiers. So access modifiers are useful if you ever want to write code that other people will actually use because you don't want them to be able to mess with your stuff, right? There are some cases where when people have access to the internals of your code, they might be able to do some nefarious things. So we have 4 levels of access. The first is private, which is the tightest level of privacy. Variables and functions with this modifier can only be accessed by that same class. They can't even be accessed by subclasses. They can, however, be accessed by nested classes within. So if you have a class within a class, which is possible, by the way, if you didn't know, those can access that private variable, but nothing else can. Next, package private, which is the default level of privacy. If you don't put any access modifier, that's what's happening. Variables and functions with this modifier can be accessed by classes within the same package, but not outside classes, even if those outside classes are subclassing or extending this class. So even if your own subclass, if it's not in the same package, cannot access this variable or method. Protected is kind of just slightly a step above that. It's very similar to package private, except that you can access variables through subclasses that are in other packages as well. Lastly, public is the loosest level. Variables and functions with the public modifier can be accessed by all classes in all packages. Next, we're going to talk quickly about bitwise operations. So there are 7 bitwise operations that you need to be aware of and comfortable using. The first is a mask, otherwise known as an AND. And in this situation, if both of the bits in the same position are 1, then the result will be a 1 at that position, otherwise the 0. So 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, and 0 and 0 is 0. Next, we have an OR or set operator, and in this situation, if either of the bits at that position in each of the 2 bit numbers is 1, then the result will be 1. So 1 and 1 is 1, 1 and 0 is 1, 0 and 1 is 1, but 0 and 0 is 0. Next, we have a flip or an XOR. In this situation, if exactly one of the bits is a 1, then it's a 1. Otherwise, it's a 0. So 1 and 1 is 0 here, but 1 and 0 is 1, and 0 and 1 is 1. 0 and 0 is 0, as always. Next, we have a flip all, also known as a negation. And in this situation, we just flip all of our bits. This is a unary operator, so you only have one number when you're doing this one. So 1 turns to 0, and 0 turns to 1. Next, we have a shift left. So in a shift left, you are shifting over the bits by 3 positions, and you are putting zeros where they used to be. So in this situation, you can see this 1 right here moves 3 positions over, and there's now 3 zeros at the end where there weren't some before. Next, we have shift logical right. Now, shift logical right, you're shifting over by 3 to the right this time, and you're just putting in zeros. And then we have shift arithmetic right. And in this situation, you shift over 3, but you, instead of just adding zeros, you add 3 of whatever that first digit used to be. And the reason you do that is because negative numbers in Java are represented by preceding 1s, and positive numbers are represented by preceding 0. So this maintains whether the number was negative or positive. Like I said, quick review. Let's get into the worksheet. So in this situation, there's a lot of stuff on the worksheet, and there's not a lot here. But the idea is we are going to fill in this reduce function in this list utils, and we're going to create 2 classes that extend this, one that does addition and one does multiplication. That extend binary functions, sorry. Okay, I'll give you a minute to think about it, and then we can go over it together. Okay, welcome back. Let's go over it. So, first things first, we want to start with this function up here. So we want to iteratively reduce the list using the function that we're given. So let's start with having some sort of variable that is like what we have so far in our reduction. Makes sense. And then we are going to create a for loop that iterates through the list from 0 to list.size and applies our function to what we have so far and list.get the next thing. There should be an extra parenthesis here. I'll fix that later before I put this up. So we have that, and then we just return so far. Okay, makes sense. Let's go through to the next part. Let's write our first binary function subclass. We could start with adder. So in this case, we're just adding. So we have adder implements binary function, and here we have our apply function, which is something that we have to implement, and it returns x plus y. Makes sense. And we're going to update up here to make sure that we can instantiate it, and when we try it out, everything works, right? We go 0, and then we add each time to our so far, and then we return. Fantastic. Let's do the next one. So the next one, we're going to write one that multiplies, and same kind of idea, where instead of addition, we do multiplication, but does it work? Well, if we actually try it out, we always get 0 because we're always multiplying by this initial 0 up here. So we can't start so far at 0. So instead, let's start with the first element. So list.get 0, and then this starts at 1, but now we have another problem, which is that we need to be prepared if list.get0 doesn't exist. So if our list is empty, then we have to just return 0. Otherwise, we're going to get an error on that line. And that is the end of our listUtils binary function problem. Sounds great. Okay, moving on. Let's get into some inheritance infiltration. So if you look at the worksheet, the goal here is to be able to extract the password using password extractor by extending password checker. So I'll give you a second to try that out, and then we will talk about it together. Okay, welcome back. So our first step is to extend password checker, and maybe we can trick login. That's an interesting place to start, right? So let's create a fake authenticate function because we are now extending password checker. Let's override it, and we're going to take in the correct things, the login and password, and we're going to set this extracted password variable we have outside to be that password, and then just return true so that it authenticates whatever. And the trick is, by having this variable outside, we can persist this password string past when the authentication is over. So now we just have to call login on the user that we pass in to extract password with our password extractor as the authenticator, and then we just return extracted password. And that's that. We won. Okay, let's do some bit stuff. So in this problem, we're trying to implement something that checks to see whether this bit is on. Bit I is on. So we're passing in an I, and we're passing in a number, and we're going to check whether in that number the ith bit is a 1 or a 0. So I'll give you a chance to try it out, and then we'll talk about it together. Okay, let's talk about it. So we have this mask. So what do we want to do? We want to mask out everything except for that ith bit, because that ith bit is the only thing that we care about. So we're going to take 1, and we're going to shift it over by I. Next, we want everywhere except the ith bit. We know that when we, we know that when we use an AND operator between mask and num, that everywhere except the ith bit will definitely be 0, right? Because mask is 0 at all of those places, and we need both of them to be 1 for it to be 1. So if the ith bit is 0 as well, then this whole number will definitely equal 0, and otherwise it'll equal some other number. So all we have to do is check whether or not mask and num is equal to 0. If it is, then we know that that bit is a 0, and if it isn't, we know that bit is a 1. So we check to see that it's not equal to 0 to kind of flip that and return false if it's 0 and true if it's not. kind of a similar problem. This time, instead of checking to see if bit is on, we're going to turn the ith bit on. So I'll give you a chance to think about it, and then we will go over it together. Okay, let's go over it. So the mask here is going to be pretty similar to the previous problem because, again, we only really care about that ith bit. And this time we're not anding, we're going to be ORing, right? Because all the other bits will stay the same because our mask will be 0. So if num was 0 in that position, then the result will be 0 still. And if num was 1 in that position, the result will still be 1. Only at the ith position will it definitely turn to 1 now because we now have the mask has 1 there, so anything or 1 will always be 1. And now, just like that, we've turned that bit on. Okay, last problem. This one's a little harder. So we are going to implement something called flip halves. And the idea here is that we take the first half and then we flip everything. We take the first number, we flip the first half, and then we take the second number and we flip the second half and we put those together. Kind of complicated, but I'll give you a chance to try it out if you want to figure out what this means. There's an example up there. The example is in hex, by the way. That's what 0x means. 0b means binary. I'll give you a chance. Okay, let's go for it. So let's create our mask. So this time we're creating a mask that is 1s for the first half and 0s for the second half. And we can kind of dual use this as a mask for both of ours, even though that might be kind of confusing at first. So first, let's try to get the first half of our result. So we want mask A greater XOR A, and that'll flip the bits using XOR. It's because 0 and then XOR 1 is equal to 1, and 1 XOR 1 is equal to 0. So we're going to use this flip, and then we just mask out the second half completely by using AND with this mask we've made. So we have flipped all the bits in the first half of mask, and now we're masking out the second half completely using AND. Now we can do the second half. It'll be the same, but the idea will be reversed because we're doing the second half instead. So we're going to reverse mask so that instead of being 1s for 16 and then 0s for 16, it's instead going to be 0s for the first 16 and 1s for the second 16. And then we're going to XOR that with B to flip all of the bits in the second half. Next, we're going to mask out the first half by using the and the, again, flipped mask, the negated mask that we have. And then we combine it with the previous part with a OR. And this way, the first half, because we know that the second half of this first part is going to be all 0s, and the first half of this phrase is all going to be 0s. So when we do OR, it'll basically just combine these perfectly. If you're confused about that, try writing out a simple example. Anyway, that brings us to the end of this worksheet. I hope you guys had a good time, and I'll see you guys next week. Bye!